So before this, we have a question that has been posted here and has also appeared in the CAT in the 2019 paper, if I'm not mistaken. So this is the question. And there are two approaches to solve this. The first approach is what you'll find on all online fora by the CAT toppers, by CAT experts, by every other CAT expert on the internet. And you'll find people that have aced the CAT to be unanimous in solving with this method. And the second method is, I don't think it's my own, it's a very simple method, but for some reason nobody has uh, solved this question using that method yet as of now in my knowledge. So let us discuss both methods one by one. So let us populate the values in this chart of colors that we have. So let the red ball stand for cricket. So label it C, and the number that we put here is 132. So 132 represents the entirety of the red circle, even the part which is obscured by the yellow and blue lines. The yellow circle, let's say, let it stand for tennis, and hence its number size will be 123. And blue, the set, let it represent football for no real reason, and let its number cardinality number be 144. Let's put a 144 here. All right. So yeah, I couldn't resist to match colors, but then yeah, red for cricket, tennis, yellow ball, easy to remember, but football blue just for some reason. And that's that. So let's use the traditional method first, which everyone has used to solve it, but which I think is unnecessarily lengthy when a shorter method exists. So the traditional method is using this formula, which goes n of A union B union C equals NA plus NB plus NC, which is tedious to write. So let's just write the numbers themselves. So it's NA plus NB plus NC, NA plus NB plus NC. So it's 132 plus 144 plus 123. So NA plus NB plus NC, 144 plus 123. So this is a simple sum of all the members, but then we are double counting members. So let us subtract the bisections, the double overlaps, the double intersections. So let's put in the values of intersection as provided in the question. So let's go with 132. So let's go with F intersection T first. Like everything is commutative, so it doesn't matter a lot right now. So let's go with 58. And then let's go with C intersection T, which is cricket and tennis, and that is 25. And let us go with the last one, which is 63 for football and cricket. Okay. The order really is not important here. So this is it. And then since we have overcompensated it, because even the double intersections themselves create a triple intersection, let's add that triple intersection. Let's add that trisection to compensate the compensation in turn. And that is unknown, unfortunately. So let's write it as X. Now we have to perform one step, two step, one operation, two operation, three operation, four operations, five operations, six operations, and then one transposition to subtract this from here. So seven operations when we transpose this. And this number is nothing but 256. So 256 is the total number of humans, total number of people, total number of persons, total number of members in the club. Whereas this simple addition yields more, since some members are common and shared by multiple sports. So we perform this subtraction, and it's 132 plus 144 plus 123 minus 58 minus 25 minus 63, which will come as 253. We after right, so we have 253, and then we have plus x. So we had to perform 5 operations at this point, and then a 6th operation when I send it here, right? So a 6th operation here, and we have x is equal to 3. So after 6 operations, 5 of these sort, and then one transposition, subtraction, that is x is equal to 3. We have 6 operations, and we don't have the answer yet. 3 is the number of people who lie in the brown region, the dark brown region. This region, a dark shade of brown. Now, in order to find the answer, what has been asked of us in the question is the number of people who play only tennis, which is represented by this sort of semi-lunar structure, this sort of like Jedi symbol yellow structure here, right? Which is basically the tennis, the all the people that play tennis minus any minus everyone who plays any other game, whatever be it cricket or football, and both cricket and football. So yeah, pure tennis players, so to speak, in a manner. So this can be obtained by taking the entirety of tennis players, that is 123, and subtracting two intersections, which are cricket intersection tennis, and the value of cricket intersection tennis given in the question is 25, and then again tennis intersection football, and the value of tennis intersection football is given as 58. So we subtract these two and look at the number of operations we have, and then we are not done yet because we have again overcompensated while awarding compensation subtractively. So let's recompensate it additively and add the dark brown region to it, for it was the very reason we calculated it. So let's add 3 here, and let's crunch all these numbers together and see what we obtain as the answer, and we'll get a neat 43, which happens to be the answer to this question. We have 43 here. Now this method took 6 steps here, and 6 operations here, 7 operations, 8 operations, and 9 operations. It took a total of 9 operations to perform this calculation. So finally we have our answer. Now let's see if we can do it in much shorter span of time using the method that I propose. It's not really a method, but it's just simple observation which somehow nobody has happened to have made or stumbled upon. And this was the first thought that came to my mind when I saw this question. So we are required directly to find this area. Can we do this? So as you would have noticed in the last question, the majority of steps were required to find this little centric dark brown region. Can we forego that? Can we bypass finding this dark brown region by some method? So what I can suggest, what I can spontaneously see is that let's look at this figure in its entirety, what we call NA union B union C. So this is not the sum of 3 circles. It is slightly less than the sum of 3 circles because they're overlapping. So this floral outline that you see, this is nothing but 256. Now, out of this floral outline, if I subtract this lemniscate or 8-shaped figure, this 8-shaped figure, this one, I think that is going to give us the shape that we require. And this 8-shaped figure, which let me just mark in a bright fuchsia or pink, this 8-shaped figure that you see here, very roughly, pardon my light-handedness, this 8-shaped figure, if I subtract this dumbbell shaped figure, I hope I made myself clear, the red plus blue, red and blue region, red union blue region rather. So if we subtract this from the entirety, I think we can obtain this the yellow semi-lunar so region that we are looking for. So let us just do that. So the total is 256, and out of this total we need this red plus blue. So I'll subtract the red, which stands for cricket, and which was 132, and then also subtract from it the football, which was 144. So let's write it in this form, and then later open it up so it will be more intuitive to see. So when this opens, it will become a subtraction sign. So 132 plus 144, and we since we have taken this away, we also need to compensate with this this violet region, including the brown region, because some of the violet region is obscured behind the brown region for the simple reason that the orange and green overlap there. So this entire violet leaf, so to speak, so this is nothing but the intersection of cricket and football, the value for which is provided as 63. So see, I did not use even most of the data here. So 63. So let's subtract it. So when I open the signs, each of the signs will invert since there is a minus sign on the outside. I did not use all of the data that is provided. So I think much of the information given is superfluous. I don't need all of the data. So if you perform this calculation, then you get 132 plus 144, which is 276, and minus 63, which is 213, and 256 minus 213. So it's going to be 256 minus 213. And we directly have our answer, which comes out to be neat and clean 43. And that is exactly the answer that we needed. And look at the number of operations that we had to perform. So we had to perform 1, 2, and 3, only 3 operations. This is the one that you see here. I just written it for the sake of clarity. So only 3 operations compared to 9 in the previous one, using using only a bit of the data that is provided. So 9 operations reduced to 3 operations. So that's the beauty of this method. Hope you like it. Thank you, and have a good day. Thank you.